So we've got a question here. We've got a 10 kilo box which is pulled along by a rope. The tension in the rope is 60 newtons at a 20-degree angle. The coefficient of friction is 0.2 and we want to calculate the acceleration. So the first thing we'll do, draw a forces diagram. So that can be the horizontal plane, and the box can represent here, the rectangle can represent the box, which is 10 kilos. Okay, now we can draw the force, which has a magnitude of 60 newtons at a 20-degree angle. So let's draw that onto there. So then we'll have a 20-degree angle represented. So that's the forces acting on our box that are given in the question, and the coefficient of friction, I'm just going to write that as there as 0.2. Okay, right. Now what we want to do next is to draw in the forces that are on there that we can fill in to try and find our answer. So first of all, we'll have a resulting vertical force, which will be counteracted by the force of gravity. The force of gravity is the mass of the box times the gravitational constant, which is 9.8. So this will be our resultant vertical force. We'll also have a resultant horizontal force going in this direction, counteracting the tension in the rope. So now we call this force F. So what we need to do now is calculate these two forces, and then from then we can try and calculate the acceleration. So as the rope is pulling this along, it's pulling it along in this direction. So therefore this force here will be opposing this force here. But the vertical force, there will be no vertical motion, so this force will be equal to this force. So let's work out what that is. So our force R, that's our resultant vertical force, will be mg, which is the force going downwards, so mass times gravity, and then we can subtract any vertical coming from this rope tension. So if we draw a line down here, we can then calculate the tension in the rope in a vertical manner. So as it's opposite the 20 degrees, we can use sine of 20 multiplied by the magnitude. So minus 60 sine of 20 degrees. So that's our force R. Next we need to calculate the force F. So F. So what we need to do now is oppose the force going in this direction. So that will be calculated by the magnitude and length of this part here. So as it's adjacent to the 20, it'll be cosine and multiplied by the magnitude, which is 60. So 60 cosine of 20. Now as the box is moving, with the coefficient of friction, we need F equals mu times R, so we can use that force there. So mu with the coefficient of friction is 0.2, so therefore our F equals 0.2 times R, which is mg, minus 60 sine of 20. Okay, right, now the resultant force here, this one here, is going to be 60 cosine 20 minus F, as we're going to try and calculate our acceleration. So 60 cosine 20 minus F. That's our resultant force using the second law of motion due to acceleration. So now what we can write is, as due to acceleration the force is ma, which is mass times acceleration, we can write that as 60 cosine 20 minus this in here, so 0.2, I can just put that as 1 over 5, so I divide all this by 5. So mass is 10 times g, which is 98, minus 60 times sine 20. So just squeeze that in there and divide everybody by 5. Okay, so now to get acceleration on its own, we need to divide by the mass. The mass is 10, so divide everything by 10. So acceleration will be, divide this by 10, I get 6 cosine 20 minus, so instead of dividing by 5, I divide that by 50. So minus 98 minus 60 sine 20 divided by 50. Okay, let's calculate what that is. So 6 cosine of 20 minus 98 minus 60 sine 20, and that's divided by 50. So that gives me approximately 4.09, just to 3 significant figures. So that will be meters per second squared. So that's going to give me my acceleration. Okay,